In this demonstration, I will briefly show you the basic syntax of Python. Now, this recording is not supposed to be comprehensive because obviously there's a lot to the Python syntax, but I wanted to give you a little bit of a demonstration so that you have some sense of how one would go about writing some Python code. The primary reference material, if you would like to look up the Python syntax, is located in the Learn Python for Research GitHub repository. Make sure that whenever you try to solve the Python problems, you have these reference notebooks open. For this particular section, you will need to use the Learn Python for Research 0 Python Basics notebook file. If you use this file, it's best to click on this link right here because this link will allow you to click on the table of contents. And then the way that you expect to use this would be, let's say you're doing something, you need to write a function, and you're like, well, I kind of forgot how to do that. You would go into this reference notebook, you would go and click on functions, and then that will give you some examples as to how you would go about making functions. So how would one go about writing Python code? So let's say we've set everything up, we have our environment set up, we know how to open up Jupyter Labs, we know how to use Jupyter Notebooks, there's separate recordings for all of these, and now we're ready to start coding. A basic element of Python and any programming language for that matter would be variables. Python has a wide variety of variables. For example, if we were to define a variable that contains my name, we would do something like this. Very straightforward. Now, a variable can contain essentially anything. So it can contain a string, as indicated here by the fact that this is red and indicated by the apostrophes. It can contain numbers, but it can also contain any data structure or any object that Python is able to create. So here, and then we would run this. We can give it a number. We can also give it a list. So a list would be a collection of different Python objects. So in this case, we can say, well, we want a list, and we want that to be 0. We want that to be the letter A. And we would also like to add my name to the mix, which we've defined before, because why not? And then here you can see we now have a list, and we can reference the items in this list by using square brackets. So if we do 0, then we get the first item. Note Python starts counting from 0, not from 1. So if we were to do 2, then we would get the last item. If we don't know exactly how long a list is, we can also do -1, so that it gets the last item of the list by looking through it backwards. Besides strings and numbers and lists, a very common Python data structure would be a dictionary. And a dictionary is very versatile, which is a dictionary is somewhat like a list, but then instead of relying on the order in order to retrieve items, you have key value pairs. So if we were to create a dictionary, I'll just call it dictionary. We would use these curly brackets to indicate that we want to get a dictionary. And then we could say, well, let's do name. And then we can put there ts. And then we could put, let's say, location. We could put Seattle. And then if we were to run this, then a dictionary does not have an order per se. So that means that we cannot do something like this, because then we'll get a warning. And this is how a Python warning would usually look like, where it says, well, there's a key error because I do not know what 0 means. It's going to look for a key named 0, but that doesn't exist. So if we were to get if we would want to get some of these items out of this dictionary, what we would have to do is we would have to specify a key. And the keys that we have in this case would be name and location. So if we were to do name, then it's going to look up the value that's associated with the key name, and then it's going to return that to us. So these dictionaries are very useful. They're very easy to read because if I see dictionary name, you know that I'm trying to retrieve the name key value pair out of this. Whereas if you look at names, you're not necessarily sure by looking at the code what you're trying to retrieve, because 0, 1, 2, 3, it doesn't really make too much sense for many items. But the combination of lists and dictionaries and strings and numbers, those will be the far majority of kind of data structures that you will use within the realm of just native Python code. You can also combine these two together. So if we were to have a dictionary, then what we could also do is if we said something like items And then we could say key, phone, whatever. But you can see here that we're essentially embedding a list inside that dictionary. And then whenever we were to get a item out of the dictionary, and notice here that what I did is I was typing and I was kind of lazy and I didn't want to have to type out that entire variable name. So what you can do is you can click tab, and tab will open up autocomplete. And then here I can just click this one. So I use the arrow keys and then I press enter, and then I don't need to type out the entire thing. So that can save you some time. And then I can say here dictionary, and then I would do items. And now I got that list that's being retrieved based on the key items. You can loop over lists, you can loop over dictionaries. So if we were to want to loop over that initial list, we do for, and then we can give it any reference we want. Let's call it item in LST. And then we can do a print statement. And then it's going to loop over every item that's in list. And then we can do something with it by referencing to the name that we gave it, which in this case is item. We can also loop over a dictionary. But if we want to loop over a dictionary, we get two things returned because we get the key and the value. So we would do for key value, and you can call this any way you want, but I like to use key value. So for key value in, and then dictionary. But here we do have to tell Python that we want to loop over a dictionary. So we have to add dot items. And then if we were to do print key value, and then we'll loop over it, and we can access the key and the value separately in each iteration. If you do not know how long you will need to iterate for, then what you could do is you could use a while statement. Now a while statement will loop until something breaks the loop. So that can be one of two things. You can say, well, let's say that we specify a count variable. This is just a variable with the number 0. And we say while count is below 10, loop, keep looping. And then what we can do is we can say, well, in every iteration, add one item to the count. And notice here, I don't actually need to specify something specific. I can just say count plus equals 1, which will say add 1 to it. Alternatively, what I could do is I could say, well, override count with count plus 1, and that will boil down to the same thing. And now what this will do, and I can do print count here, then this will keep looping until count hits 10, and then it will stop looping. Now these while statements, they can be useful, but if you know in advance how many times you want to loop, then generally it would be better to do something like this, where you specify a for loop with a fixed amount of iterations you want to do, such as this, for example. And you can use the range function here so that you don't have to specify 0, 1, 2, 3, 4. If you just say range 10, then this will boil down to a list that has the different values in it, as you can see here. So here you can see we now have a list that is 0, 1, 2, 3, 4, 5 until 9, which is 10 items. And we can double check that this is indeed 10 by doing len. So you can see the length of this is 10. And then if we were to do print I, then we get the same thing as here. The only thing is that because we specified print after adding 1, and here it does 1 to 10, and here it does 0 to 9. But the logic is exactly the same. Now, an alternative thing that you can do whenever you do while loops, and this is where you would generally use while loops, is that you might not know how long you have to kind of loop over, because maybe you have some condition, maybe there's some randomness involved, and you don't know whether you need to do 5 iterations or 10 or 20 or however many. Then what you could do is you could specify a while loop, and you would do while true. Now, a while true loop can be a little dangerous because that will run forever until you specify a break statement. So let's say we have this loop that will go forever, but we want to generate a random number that's in 0 to 10. And if that random number is, let's say, larger than 5, we want to stop the loop. This brings me immediately to the import statements, because an import statement, if we want to use a random, if we want to generate a random number, we would have to import the random library. And this comes prepackaged with any Python installation. So you do import random. And then what we can do is there is a function called random. And then again, if I don't know the function I want, I can click tab. That will give me the various options. So I can kind of look through everything. And then we see here rand int, which means a random integer. So we can click that. Then we would put brackets, and this is where another shortcut comes in handy, because let's say we don't know exactly what this takes. Like we know it probably takes something, but we don't know. We can go onto Google, we can look up the random library, and we can do it that way. But we can also click Shift Tab, and Shift Tab will open up the kind of a little piece of the documentation that gives us information as to what this exactly takes as parameters. So we see here, it's a rand in, it takes A and B, and then it generates a random integer in the range A to B, including both endpoints. So if we do 0 to 10, then that will generate a number that's either 0 or 10 or anything in between. And there's integers, so it's 0, 1, 2, 3, 4, 5, etc. And then as we can see, anytime we run this, we get a random number. So now let's say we take this, we put it in here, and we say, we save this output so we can create an if statement. And then here I can also immediately introduce if statements, which are very straightforward. So I can say if random number, and again, I use that tab shortcut here. If the random number is above 5, then break. And the break statement will indicate that whatever you're currently looping, just break that iterations. So stop looping and kind of end the code there and move on to the next line that's out of the loop. So if I were to then run this, now in this case, we don't really know how many times it took for this to run. So let's say we add a little print statement here. So then first it got 5, well that was not above 10, so it didn't stop. The second one was 2, so that also didn't stop. But then it got 7, so that was above 5, so it braked. But depending on how many times we run this, it might take longer, it might take shorter, we don't exactly know because it's random. So that's where that while statement can be useful. Okay, so the final thing that I want to show you is functions. So these functions are essentially a concentrated piece of code that you would like to repeat over and over, but you want to potentially change some input or some parameter. So let's say that we want to generate a function that will print a particular message for us, but we want to change some of the values in that message. Okay, so let's say we want to change the name. We could use something like a variable and string, but let's say we want to do some complicated things. So just for the sake of an easy example. So we would create a function and we would do def from define, and then we say generate message. Okay. And then if we would just put brackets and we don't put anything in it, it doesn't take any parameters. It's always just going to do the same thing, which might be useful if you just want to contain a piece of logic in a function so that every time you call that logic and you want to redo that logic, you don't need to specify the whole thing. You can just refer to one line, which is the message or the function. So let's say we do here, and then we do message would be, hello, this is Tees. Okay. And then we can do return, and return will specify what we want this function to output. So we do message, and then if we want to run this, now note whenever I define this function, it's not running any code. We just defined the logic, but we didn't execute it. Okay. So in this case, if we were to now reference to this function, and again, I can use autocomplete using tab, then what we get is we run this, it doesn't take any inputs, so we don't have to specify that, and then it will execute this function. Now, this is not super useful. Let's say that we want to add a parameter to this function so that we can change the name that's being printed. So we specify name here, and then here we can specify a string with a variable in the string. So we do curly brackets, and then we do format, and then we specify name. So this means that it's going to take the name input, which is a parameter. It's going to put that right here, and then it's going to inject that into the string where these curly brackets are located. So now if I try to run this, it's going to give me an error message because it says, well, I tried to run this, but it's missing a required positional argument, which is name, which is that first one that we specified here. So if I were to do this, and then I specify now, let's say call it Peter, then it's going to change. If I change this to something else, like Anna, then you can see that that changes. Now we can also give this a default parameter, because let's say that we we don't want to always have to put this input in. Because, for example, let's say that we're creating a function and we want to have a debug function where it's just going to print some additional information. This can be useful if you write a bunch of functions and you just want to figure out what's going on, but you don't want to print a lot of messages every time because that will just kind of make everything very messy. So only when you're debugging something, you might want to print that. So let's say that we add a debug parameter. So we do debug, but we don't want to have to specify that every time. So let's say that by default, we want to give that false. So that by default, if we don't specify it, it's not going to run whatever we specify with that debug. So we have that now set up, and then we can say, well, let's say that we just want to know what the length of that message is. Then we can say if debug, and notice here that it's going to test, like an if statement looks for true or false. But if the content of whatever we're using as a condition is true or false, we don't need to say if debug is false or if debug is true, because it will automatically kind of resolve it by the fact that debug is going to be true or false by nature. So if debug, which is if debug is true, then print the length of the message, for example. And then we run this again. And then if we run this, it's going to say, well, by default, debug is false, so it's not going to print it. But then if we add to this and we say debug is true, then it's going to print the length for us. The only thing worth noting here is that you can tell here we didn't specify name. We could say name equals this, and that will work just fine. But because of the fact that we didn't specify a default, it will just say anything that is entered first without any specific kind of variable name attached to it. It's just going to assume that that's the first item in the function parameter inputs. But here, anything that has a default value, you need to specify the name, because otherwise it doesn't know what that input corresponds to. That is the end of the demonstration. I wish you good luck with the problems.